Students, in the previous video session you have gone through Wheatstone's bridge, and today we can see just an application for data. Here you can see an example 2.24. It is one of the very important 3-mark problem. Previously in many exams they asked this problem, so practice this problem. So let us see what is the value of x when the Wheatstone's network is balanced. P is 500, Q is 800, R is x plus 400 and S is 1000. This is the data given. You see P, this resistor 500, this resistor Q 800, this resistor R means here x is there, 400 is there. So both you can add. Then 1000 is there. We know the formula P by Q is equal to R by S. So P is 500, Q is 800, R is x plus 400, then S means 1000. Now just to do the cross multiplication, 1000 into 500, then what are 800. So before that you cut this 0 0 0 0. So 1000 into 5 is what are 5000. 5000 divided by 8. Or you can do like this. You take this 5 divided by 8 into 1000, you take it here, cross multiplication, x plus 400. So here while calculating this 8 cancel this 1 times, then 2, one times, and then 2 is remainder in 28 2 times, so 16, then 4 is the remainder 5 times, what are, yeah, so 125 into 5, that means what are 625 will come. So 625 is equal to x plus 400. So x plus 400 equal to 625. So x is equal to 625 minus 400. So x is equal to 225 ohm. So you can take a screenshot of this. This is just a simple problem. So we know that P is 500, Q is 800, R is x plus 400 and S is 1000. Just to do the cross multiplication, and addition, so you will get the answer 225 ohm. So this is very important problem, 3-mark problem. Practice this. Next one is meter bridge. Actually this is another form of Wheatstone's bridge. This is called as meter bridge. You can see this meter bridge, and this is how it looks, and you can see this diagram. Actually while doing the practical session we will show you this device we have in the laboratory, and you will do experiment also with this. Okay, so we'll show you this meter bridge. Now you see how it is made up of. You see here you can see one wire. This wire is made up of a material which is called manganese, and AB. AB is this wire, 1 meter length. Its length is 1 meter. So a wire which is made up of 1 meter length is attached between these 2 points AB, isn't it? So that is what the first thing. So this wire specialty which is made up of what? Manganese material. Now you see along with this wire you can see a meter scale. So this wire is stretched between these what? 2 point, and along with this 1 meter scale is attached on this wooden board. So next thing is you can see two copper strip. This is one copper strip. This is another copper strip. So two copper strip, you can keep it as C and D, which is also what attached on this wooden border from the point this AB. So now you see one another copper strip E. This is another copper strip E, which is mounted between this copper strip C and D, and there is a gap between these two gap G1 and G2 you can see, and this gap only we are connecting the non-resistance and unknown resistance. That is what you can see in the next paragraph. So an unknown resistance P is an unknown resistance, and Q is a standard resistance. So you can tell that we will connect in the laboratory on resistance box. So two resistance which is connected with this gap G1 and G2, and from this copper strip E you can see another wire, no? So another connection. So this is what a jockey. This is what we are saying, jockey. Jockey means we can see it is a pen-like structure. So that all we will see later. And this jockey is connected between this from the center of this copper strip E. Along with that, one galvanometer is connected. Also a high resistance box HR. HR means a high resistance box, and a galvanometer is attached from the center of this copper strip E. Now you see this is what a simple construction, and what is the use of this jockey means what when we are moving this jockey along with this wire, what will happen means this galvanometer will get a deflector. So along with this from the point A and B, it is connected with a cell and a key. Cell its EMF is epsilon and a key K. And here we are using Lagrange cell. We have Lagrange cell and Daniell cell and all. So we are using here Lagrange cell. Now you can see that how we are doing this experiment means actually when we are moving this jockey on this wire, we can see that this galvanometer is shows some deflection. So what we will do means we will move this jockey till the galvanometer shows null deflection. Null deflection means zero deflection. Once the galvanometer shows the null deflection or zero deflection, what we will do, we will take this length, either this AJ and this JB we are calculating, we are noting down. That is what our experiment, and that is what we are substituting in this formula. P by Q is equal to R by S, which is equal to R dot AJ divided by R dot JB. What is this? R means resistance per unit length, we will say. And now you see, I said that here we are taking our formula P by Q is equal to R by S. Already we have found the balancing length. So P by Q is equal to, we are taking AJ by JB. And this AJ is, you can take L1 and JB we can take L2. So P by Q is equal to L1 by L2. From this P we can find, P is an unknown resistance. Q value we know because we are setting. Balancing length L1 means AJ and JB means L2. So now we can easily find out the value of this P by using this formula. I believe that if I understood something, again I will tell. You see, this is just how a meter bridge. Just it is very simple. You look at this diagram and say this story. So first thing you start from this what this is another form of Wheatstone's bridge, isn't it? This is another form of Wheatstone's bridge, and now how it is made up of, just you can explain this thing, no? First thing, uniform wire of 1 meter length. We are starting from here, which is made up of manganese, which is attached on a wooden board, no? So at the point AB. Now you have to tell about this. So you see this 1 meter length manganese wire is attached at the point AB. Now another 2 copper strip. This is 1 copper strip. This is another copper strip. 2 copper strip C and D, which is what? Which is wounded on this. Wound you can tell, or you can fix on this wooden board. This is a wooden board, and on that wooden board, this 2 copper strip is fixed. In between, another copper strip is also fixed with gap G1 and G2. So this is what first construction. Now you can tell about you see in the gap G1 an unknown resistance P is connected. This is what we are going to find. Just how we are doing means we will just connect a wire. Wire means aluminum wire or copper wire, and we don't know the value of that resistance. Just we will connect in this gap, and in this gap we will connect another resistance box. That is what we are saying standard resistance. There we will fix the values and do the practical. And while doing this thing, what we are doing means we are finding this unknown resistance P. That we have to keep it in mind. And for that only, what here we are connecting on standard resistance. Now from the center of this copper strip E, from the center of this copper strip E, a jockey is connected. This is what a jockey. So a jockey is connected with what? A galvanometer and a high resistance box from the center of this copper strip E. Okay. Now you see. This jockey, we know that I told that we can move over this wire and we can fix the exact position, and that position will show, that position we are reading by using this meter scale, and this meter scale is attached on this wooden board along with this water manganese wire, or you can tell that wire. Now, now how we are doing this practical? Actually, before that, you have to tell about from the point A and B, what it is connected with a Lagrange cell and a key on this meter bridge, you can tell. Now, how it is working? Actually, this position, this when we are moving this jockey over this wire, that is what, when we are moving this jockey over this wire, what will happen? This galvanometer deflect. So when the jockey reach, we will move like this along with this. Maybe when I am reaching, when the jockey position is here, now what happened means galvanometer shown 0 deflection. So you have to stop it here. Once you stop means what? Once the galvanometer shows 0 deflection, you have to stop the jockey at this point and straight to this you have to measure this length. And this length is AJ. And another length is what? J to B. So AJ, you can take JB. Now, based on data, we are doing the calculation, no? So, we know that the formula P by Q is equal to R by S. This is what the meter bridge formula. Here, we can take a P by Q is equal to AJ by JB. So here R dot given, and this is resistance per unit length, no need of data. So P by Q is equal to what? AJ means length 1, JB means L2. This is what? L1 by L2, length 1, length 2. Now we need to find out this P. This is the unknown resistance. This value only we want to find out. So we are keeping the P here, taking the Q. So L1 by L2. So now we can find out the unknown resistance P. Now we are finding, you can find in this practical we can find the specific resistance also. Specific resistance means, or you can tell that a resistivity, specific resistance or resistivity. Rho also we can find the specific resistance or resistivity. How we can find the means, we know that formula, resistance equal to rho L by A. L means length, A means area. Actually we are using an unknown resistor in the gap G1. So here we are using unknown resistance. So this resistance length we will measure by using meter scale. Also we will measure the thickness or the radius of this wire by using screw gauge. So we will find out the length of this unknown resistor, radius of this unknown resistor. Now we will use this formula, resistance is equal to rho into L by A. Here we need to find out the resistivity rho. So rho is equal to resistance into A by L. So rho is equal to resistance into A by L. This is just a cross multiplication. We are taking this rho here and A here. So rho here we are keeping, and A by A taking upside, L is taking down. Now rho is equal to resistance means standard resistance, maybe 2 ohm we are using means 2 ohm, 4 ohm we are using means 4 ohm, like that we can give. So that is what resistance. And here area. So maybe like this one wire we are taking, one wire, and what we will do means we will measure this length of this wire, also thickness of this wire. So easily we can find out the area by using pi r square. So here we are using area pi into A square divided by L. So that rho is equal to, we can write P. P means what? Unknown resistance. Already we are finding by using this formula. P into pi A square by L. Now we got the resistivity also. So first you have to find out this, what unknown resistance value. Then you have to find out the resistivity by using this method. So my dear students, you go through this meter bridge. So based on this meter bridge experiment, you can go through this example problem. This is also an important problem, 2-mark problem they can ask. So in this we are finding what an unknown resistor by using the same formula. So go through this also. In meter bridge experiment, the value of resistance in the resistance box connected in the right gap is 10 ohm. The balancing length L1 is 55 centimeter. Find the value of unknown resistance. So the thing is given, only the resistance in the right gap is measured. That means Q is measured. So Q value is given. The same formula we can use and find out. So you see, Q is given 10 ohm. and we need to find out P. Okay, we need to find out P. So Q value is given 10 ohm and the P value we need to find out and here also given L1 is equal to 55 centimeter, isn't it? Now we know that formula P by Q is equal to L1 by L2, and here in the question given L1 value. Now P we need to find out. P is equal to Q into L1 by L2. So P value is given, Q value is given 10 ohm, 10 into L1 is given 55. And what is this L2? I told that between these 2.1 meter length wire is connected. If the jockey is here, this is J, and this AJ is L1, JB is L2. So we know that L1 is 55. This is 55 centimeter, means this total length is 100 centimeter. So 100 minus 55 is what? L2. That is what? Here it is taken 100 minus 55. So by calculation we will get here 550 divided by 45, and P is equal to, we will get what? 12.2 ohm. This is also an important problem. You can note it down. So thank you all. See you. Bye bye. Practice these problems. It is very important problems. Today I explained example 2.24 and example 2.26 in the page number 108 and 109. Thank you all. See you. Bye bye.